Questions on the homework?
I'm not gonna lie, I still do not understand it. I watched this video. I couldn't understand it. I can try watching it.
Questions on the homework?
Is this your smallest class?
Drake has 2.
Oh. Is that his eighth hour? I think so.
All right, guys, if there's no specific questions on the homework, we're going to go on and get started. So what we're looking at today is systems of linear equations, specifically linear equations with 3 variables. So we'll be looking at equations that have x, y, and z. Now, not all equations or all systems will have to have 3 equations with 3 variables. We'll need at least 3 equations that have at least 1 variable, if not 2 or 3. Now, this here is an example of a 3-variable system of equation. And if there is a solution, a single point, it's going to be written as an order triplet here, x, y, z, whose coordinates are true for each of the equations. So if we plug those values back into each equation, we would get a true statement, and it would work for all 3. Now, to visually look at these type of solutions or types of solutions we can get for a 3-variable system of equation, one of them would look like this here. Because when we have an equation with 3 variables, it represents a plane. And the point that all 3 planes intersect each other is considered the solution. And if there's exactly 1 solution, it will be a single point, and that point will be the point where all 3 planes intersect. So we can have exactly 1 solution. We can also have infinitely many. And when we have infinitely many solutions, it will be represented most likely by a line, because all the points on that line are going to be true for the system and give us a true statement. Now, we won't dig too deep into finding the infinitely many solutions. It is possible. We'll dig more into that, especially in the trigonometry pre-calculus class or the college algebra class, depending on which one you take. But this here is infinitely many. Now, it's not all real solutions because there are still points on the planes or in the coordinate system that don't work, because a point out here would not be true for all 3. It's only true for 1. So there are some points that would not work, but the points that do work, there's an infinite number of them. And the last one is no solution, because there is not a point or set of points that is true for all 3. Because if we look at this first one here, there are points of intersection. There's actually 3 sets of points of intersection, but it's not intersecting on all 3 planes. It's only intersecting at 2 at most. The same thing is true for this one here. We have 2 sets of points where they do cross, but it is not true for all 3. And the last one, there is no point of intersection. There's no point that they cross. So we just say that this is no solution. Now, when we're solving a no solution, we'll get at some point a statement like this here. 0 equals 1, 0 equals a number, or 2 numbers that are not equal. We get a false statement. Because at any point we obtain a false statement, it is no solution, and we are done. But if we get a true statement, 0 equals 0, 1 equals 1, then we're going to have infinitely many solutions for that one there. And these here are essentially the steps that we're going to use to solve this. Now, we're not going to be using substitution so much. We're mainly going to focus on solving these by elimination. And our first problem that we're going to look at is this one here. Now, I'm going to write out some steps, but the main first step, when we solve a system by elimination, we're going to pick a variable to eliminate. and an eliminator equation. Now do make sure to leave a little bit of room around the problem because these problems do take up a good bit of space. Now, when we pick a variable to eliminate, we're trying to pick one that we can turn into the other two. And what that means for us is if we look at the first variable x, we have 4x, 2x, and 6x. Now, normally I look at the smallest one because it's normally the one that's going to be easier to turn into the other two. In this case, it's 2x. What can we do to 2x to make it be 4x? By 2, right? Because 2x times 2 is 4x, yes? What can we do to 2x to turn it into 6x? Multiply it by 3. So x would be a good one to use for this here because we can multiply 2x by 2 and get 4x. We can multiply it by 3 and get 6x so that we can eliminate them out. Because for us to eliminate them, we need them to be the same. So we can add or subtract. Let's look at y. We have 2y, 3y, and 1y. So the smallest one out of this here is 1y. So what can we multiply by 1y to get 2y? 2. And what can we multiply by 1y to get 3? 3. So with x and y, we can see it's pretty easy to go from the smallest and get them to be the same as the other two. Let's look at z. Well, our smallest value with z is 3, yes? What would we multiply by 3z to get 4z? I mean, there are numbers, but it's not going to be something easy because to get those to be the same, I'll have to multiply 4z by 3 and 3z by 4. We have to do 2. Same with 3z and 5z because we'll have to do a similar process. So it's not as easy to get those to be the same as it is with x and y. It is possible, but we have to do a little bit more to it. And realistically, I try to avoid those or do them last. If there's no way to make it be the same easily as we see with x and y, then we would go to an example or situation like z. So the first thing we need to pick is a variable to eliminate. Do we want to eliminate x or y first? So we're going to eliminate x out first. And the next thing we're going to pick is an eliminator equation, which I'm going to pick the middle equation. I always pick the one that has the smallest variable because we want to get the variables to be the same by having them go up, not down. We want to multiply by a number, not divide. So that's our eliminator equation. Now the first thing I do is I rewrite the other two equations. Back out because they're going to be the same. We're not going to do anything to them to eliminate x out. Now I'm going to put it in the center of this page. You can do that as well and then write the scratch work on either side. But I'm going to try to keep the main work in a single column. Now we can eliminate x off the equation on the left first. And the first thing we need to do is get the 2x to be like the 4x, get 2x to turn into 4x by multiplying it by a number. What would we multiply it by? 2. So I can multiply our 2x minus 3y plus 5z equals negative 7, the whole thing by 2. So we'll do this here. I'm going to distribute the 2. 2 times 2x is 4x. 2 times negative 3y is negative 6y. And 2 times 5z is plus 10z. We can, we don't have to. Because without a sign in front of it, it's understood to be positive. And then we have negative 14. Yep. Thank you. Any questions on how we got this first equation? At this point here, we can put it underneath our other equation. Any questions on this so far? Now at this point here, we need to eliminate x out by either adding the two equations together or subtracting. So we could try adding first, because 4x plus 4x is 8. But if we wanted to be eliminated out, we need it to be 0. So addition didn't work. So we can try subtraction next. 4x minus 4x. 4 minus 4 is 0. So we would need to subtract. And if we subtract one of them, we have to subtract it for, do it to all of them. If we do it to one, we've got to do it to the rest. It would say positive because let's work left to right. So 4x minus 4x. 4 minus 4 is indeed 0. Now if we look at the next one, 2y minus negative 6y. Well, 2y is still positive. The negative negative gives us plus. So we have 2y plus 6y, which is 8y. Then we have 3z minus 10z. 3 minus 10 is negative 7z is equal to 12 minus negative 14. Negative negative makes a plus. 12 plus 14 is 26. Questions on this so far? Because if we multiply on one side, we've got to do it to the other. Yep, we're just doing it across all of them. This is why we have a 2 on the left side here and the right side. Because we're scaling the whole thing up by 2, so we're multiplying everything by 2. Well, we've now taken and done this here, eliminated x, so now I have an equation with 2 variables. We need to do it the same thing to the other side. But this time, what do I need to multiply our 2x by to get 6x? What times 2 is 6? 3. So now this time we're going to multiply the entire equation by 3. You're good. So we're scaling the whole equation up by 3 so that the x's will have the same number in front of them, so we can eliminate it out. We can cancel it out. Yeah. So 3 times 2x is 6x. 3 times negative 3y is negative 9y. 3 times 5z is plus 15z. And negative 7 times 3 is negative 21. So whichever variable we get by itself first, or which one we're wanting to eliminate, we get it eliminated from all the equations. Here we're eliminating x. So on both sides we're getting the x's to be the same. And then we're going to eliminate it out. This 3 here, what do we do with it? We multiply it by the negative 7. Mm-hmm. Yeah. Yes. Because to do this, whatever we multiply the one side by, we also have to do the other. Yeah, we have to multiply the whole thing by it. Questions on this so far?
Why did like the 2x
Plus 5z? Why did we use it on both? Because we have to use the similar equation to eliminate from both. Otherwise, we'll get a different result.
And then why did we put those two?
Because we're using those to get rid of x. Because the middle equation, our eliminator equation, is what we're using to remove x from the other two. So we need one equation to remove it from the other two. Does that make sense? Okay. Now, do we need to add or subtract the two equations? And one of the ways I remember to add or subtract, or which one I need to do, if the signs are the same, we subtract. If the signs are opposite, we add. And even with that, it's always good to actually do the calculations, not just cross it out. So in this case, since we're eliminating x, saying subtraction, just mark it out. Actually do the subtraction just to make sure we got it right. 6 minus 6 is 0. So those do indeed cancel out. Our next one, negative y minus negative 9y. So the negative makes a plus. So we have negative y plus 9y. So negative 1 plus 9. 8y. Just one. It would just be the one after it if it is negative. And the last one we have, 4z minus 15z, negative 11z, is equal to negative 3 minus negative 21. So our negative would make it. So we get the negative would make it positive. So negative 3 plus 21 is 18. And even with any of these here, we could plug these into the calculator. Like with the last one, I can say negative 3 minus negative 21. It'll tell us it's 18. The calculator can do this double negatives or convert it either way. So if you're not sure, especially with the numbers, go on and plug them in. You do not and cannot plug the variables into either calculator because the 30XS and the TI-84 Plus need a value for the variable, and it's set. Either you plug it in or someone else has, or just base set to a number. If you haven't messed with it, most likely the value that it's set to is 0, so it won't really help you. Does that make sense? Because even if I do hit X, because I can plug in X here, it tells me that it's 0. So if I plugged in 3X, it would tell me it's just 0 because it's going to do 3 times 0. But we can plug the numbers themselves in. Any questions on this here? Like if we were wanting to do the negative y plus 9y or negative y minus negative 9, I would just do the numbers in front. Negative 1 minus negative 9 tells me it's 8. Well, not quite, because we're partway there. Because we need to find the values of x, y, and z. Now, the reason we took x away is because we can't solve for 3 variables simultaneously. It's just not possible. Most likely, yes. Because what we've done is we've gone from 3 variables with 3 equations to 2 variables with and 2 equations, yes? And what we want to do next is to go from 2 equations with 2 variables to 1 equation with 1 variable. Because if I can get down to there, then we can solve for the rest. So our second step is to now pick a variable and eliminate it, which is almost similar to step 1, but we're not going to use an equation to eliminate it. We just need to pick one of the variables and use our processes with elimination to get rid of it. And just like how we picked x, I'm going to look at these two variables and see which one can I get the number in front of it to be similar or turn into the other easily. Now I'm going to look at z first, and there's a reason for it. What would I need to multiply 7 by to get it to be 11? There's not really a set number. I'd have to multiply 7 by 11, and then the 11 by 7 to get them to be the same. Yes? Okay, so it's not top on the priority list, because I would look at y next. What do I have to multiply 8 by to get it to be 8? 1. They're already the same, yes? If at any, especially this point, one of the variables already has the same number in front of it, that's the one you eliminate next. Because I don't have to do anything to this 8y to get it to be 8y. They're already the same, yes? So we can eliminate it. So our next step is just put them over the top of each other, and we're going to eliminate. Now, just like we did it before, if one of them was, say, 2 and the other is 4, we'll multiply, get the values to be the same, and then eliminate. Now the question is, do we add or subtract? Subtract. And we can make sure 8y minus 8y. 8 minus 8 is 0, yes? So that tells me the y's cancel. 7z, negative 7z minus negative 11z. Well, the negative makes a plus. Negative 7 plus 11 is 4z is equal to 26 minus 18 is so we went from 3 equations with 3 variables to 2 equations with 2 variables. Now we have 1 equation with 1 variable. I'll give you the last real step. Solve, and then solve backwards. Solve and then solve backwards. Solve and then solve backwards. Well, first thing we need to solve for is z. How can I solve this for z? So we're looking for z equals 8. How can I solve that for z? By 4. 8 divided by 4 is? So we have our first part of our answer. 2. And that part of step 3 makes sense. Solve. We're just solving for z. We're solving for whatever variable we have left. Now the solve backward part might not make a whole lot of sense, but when I say that, what I'm saying is we're just going back up the page. We're going backwards up the page. Because what I'm going to do next, scoot back up here. Well, at this point here, I do have 2 equations with 2 variables, yes? Do we know the value of one of those 2 variables? Yeah, we know the value of z. So pick one, left or right. Which one do we want to solve for y with? Because it really doesn't matter which one we pick. And you can write this step down below or up here, either way. 8, because we have 8y. Yep, no. I'm going to rewrite that again. So we have 8y minus 7. Well, we know z is 2 is equal to 26. So I just take that equation and replace z with its value. Now we're going to solve for y, because this equation now only has one variable we're solving for. Well, negative 7 times 2 would be what? Negative 14. Now, if the value of z had been negative 2, then yes. Because then we would have negative 7 times negative 2, giving us positive 14. Our next step in solving for y would be 2. And we can do that by adding 14 to both sides to get y by itself, telling us that 8y is indeed equal to 40. Exactly. So y is equal to 5. Questions on what we've done so far? So we found the value of z, we found the value of y, and now we need to find the value of x. And we keep going back up. Now we have, realistically, we have 5 different equations to pick from. Now, I say 5 because we do have these 3 here. We can use either one of these 3. But we also have this one over here and this one over here. Because the 2 that I circled in green are really just rewriting of the middle one, yes? But we just need to pick one of these 2 to get our solution. Now you can write this solution at the bottom of the page. You don't have to write it up here at the top, but this will be our final solution. We have to put it in an ordered pair. Now to find x, do we want to use equation 1, equation 2, or equation 3? Equation 1, yeah. It doesn't matter which one we pick, we just have to pick one of them. And what we're going to do with equation 1 is we're going to take, so we'll have 4x plus 2. Instead of y, we'll put its value, 5, plus 3 times 2. We'll plug z's value in. So whichever ones we have found up to this point, we'll plug in place of their variables. And now we will solve. 2 times 5 is 10. 3 times 2 is 6. Now we can combine like terms. Our 10 and 6 we can add together. 16. So at this point here, we can get x by itself, so we'll subtract 16 from both sides, telling us that 4x is equal to negative 4. And last but not least, we will divide both sides by 4, telling us x is negative 1. So our final solution is the point negative 1, 5, 2. Questions on any of this here? Now, as we can see here, there are a lot of steps in this, but really the first main step, finding a variable to eliminate and eliminating it out of both of the other 2, and then going from there and eliminating another is almost just a repeat. We're doing the same thing almost 3 times over, but that's all we're doing from one to the next. Now, if we want to check this, all I would need to do, I'm going to erase this here, try it one more time, is plug the variables back in. So I could say 4 times negative 1 plus 2 times 5 plus 3 times 2 is equal to 12. and then work this out. 4 times negative 1 is going to be negative 4. 2 times 5 is 10. 3 times 2 is 6. We get this here. Negative 4 plus 10 is 6. 6 plus 6 is indeed 12, so that one works. We can do the same thing with the middle equation. 2 times negative 1 minus 3 times 5 plus 5 times 2 is equal to negative 7. 2 times negative 1 is negative 2. Negative 3 times 5 is negative 15. And 5 times 2 is 10. Negative 2 minus 15 is negative 17. And negative 17 plus 10 is indeed negative 7. So that one works. And we do the same thing with the last one. 6 times negative 1 minus, well, now when I do need to do the eraser, minus 5 plus 4 times 2 is equal to negative 3. Well, 6 times negative 1 is negative 6. Negative 1 times 5 is negative 5. And 4 times 2 is 8. Negative 6 minus 5 is negative 11. And negative 8, or negative 11 plus 8 is indeed negative 3. So as we see here, we do get 3 true statements. So that point works for all 3. Questions on this here? When y'all